In many applications, the order of selection doesn't matter. For example, there is a clear difference between selecting 5 people for a basketball team and selecting 5 people for a survey. In one, the order matters, and in the other, it doesn't. Next, we will discuss the idea of combinations. What are they, and how to work with them? Let's start with the definition. A collection of distinct objects is called a combination. For example, THR is a combination of length 3 from letters THR. HRT is also a combination of length 3 from letters THR. Note that THR and HRT are the same combination because the order doesn't matter or doesn't exist. Another example, 1, 2 is a combination of length 2 from letters 1, 2, and 3. 2, 3, 1 is a combination of length 3 from letters 1, 2, 3, and 4. 1, 3 is a combination of length 2 from letters 1, 2, 3, and 4. Let's discuss the differences between permutations and combinations. First, let's recall the definitions. Permutation is an ordered arrangement of distinct objects, while combination is simply a collection of distinct objects without order. So the main difference is that permutation AB will not be the same as permutation BA. So we say the order matters in permutations. But the combination AB is the same as the combination BA. So we say that the order doesn't matter in combinations. For example, in selecting a committee of 3 people out of 5, each committee is a permutation. But when selecting 3 people out of 5 for a survey, each group of 3 people is a combination. Since every combination of length k can be further arranged in order, the number of permutations of length k is k factorial times larger than the number of combinations of length k. In any way, we want to find out how many combinations of length k out of n letters are there. Let's denote this unknown quantity as nck. Based on the fact that the number of permutations of length k is k factorial times larger than the number of combinations of length k, we obtain the following formula. Let's divide both sides by k factorial to get the following result. And now let's replace npk with the expression from the permutation formula. As a result, we get the following formula for computing the number of combinations of size k out of n letters. We call this formula the combination rule. And let's do a few applications of it. How many combinations of length 2 out of 5 letters are there? The answer is 5c2, which we can now compute using the formula. Next, let's find how many combinations of length 4 out of 10 letters are there. The answer is 10c4, which we now can compute using the formula. Alternatively, the following notation is commonly used in the literature, and we frequently read these symbols as n choose k. The following questions: how many ways are there to select 3 people out of 6 for a survey? And how many ways are there to select 3 pieces of art out of 6 to donate? Along with many other questions, have the same answer: 6 choose 3. Similarly, the following questions: how many ways are there to select 5 people out of 9 for a survey? And how many ways are there to select 5 pieces of art out of 9 to donate? Along with many other questions, have the same answer: 9 choose 5. We discussed the idea of combinations, which is, along with permutations, is one of the building blocks of the combinatorics.